we are going to talk about Newton's first laws of motion. And state that when an object is at rest, will continue at rest. When an object is moving, will continue moving until the external force is applied on it. What it means there is that whenever you have got an object, let's say here is our object. Now this object is at rest, it's not moving. Okay, this object will continue moving, will continue being at rest just like this. Okay, then when we have got an object which is moving, let's have our object moving. So if this object is moving with constant velocity, this object will continue moving, will not stop, will continue moving unless the condition is unless the external force is applied on it. That's when we can cause changes. So the moment when the external forces applied on this object, then this object now which was at rest is going to start moving. At the same time, when the external force is applied on the object which was moving, it will stop moving. Okay, so that is the basic idea behind first laws of motion. To say that when an object is at rest, will continue at rest. When an object is moving, will continue moving until the external force is applied on it. Now, there is also what we call, under first Newton's laws of motion, there's also what we call inertia. Let's say you have an object, which is here. Now, this object is mounted. Okay, this is the surface. Now you try to push this object in this manner. You try to apply the force. So this object will go in this direction, will come back in this direction, will go back there until it comes back to its original position. So that is what we call inertia, the property of the body to resist its motion. So now you may think of this. You are in a car and then the car is moving at a very high speed. Then suddenly the driver applies the brakes. What you are going to discover is that you are going to move. There you go forward, backward, until you come back to the original position. So the only thing that makes you to come to the original position, that is what we call inertia. The tendency of the body to resist its motion. So that is basically Newton's first law of motion. Okay, let's talk about Newton's second laws of motion. So Newton's second laws of motion state that the acceleration and mass, they are inverse proportion to each other. Okay, so the acceleration is inverse proportion to the mass. What it means there is that we know that the force is given by the mass times acceleration. So whenever we are trying to find the acceleration, we can divide both sides by the mass, even here by the mass. We can see that the acceleration is going to be equal to the force divided by the mass. So as we can see here, we can see that when the acceleration goes up, the mass has to go down. When the acceleration goes down, the mass has to go up. Okay, so now, whenever we are talking about Newton's second laws of motion, just know that the acceleration and the mass, they are inverse proportion to each other. So let's say we have an object. Okay, let's say we have an object, and then this object has got the mass of 20 kgs. Okay, then we have the force that is pushing this object, the block. Let's say it is 15 newtons. So to find the acceleration, according to Newton's second laws of motion, we know that the force is equal to mass times acceleration. Okay, so we have the force, which is 15 newtons. We have the mass, which is the 20. So we want to find the acceleration. We divide both sides by the mass. We can see that acceleration is going to be equal to, we have 15 divided by what? Divided by 20. So we can see that our acceleration is going to be 0.75 meters per second squared. So now, as you can see, we had the mass of 20 and the acceleration has reduced to what? To 0.75. So as long as the mass goes up, the acceleration has to go down. Now let's try to reduce the mass. Okay, we see what we are going to have. Let's say we have an object. Let's say we have the mass. Okay, let's have the mass of 5 kgs and we maintain the force. The applied force is 15 newtons. So let's find the acceleration. So according to Newton's second laws, we know that the force is equal to the mass times acceleration. Okay, so the force is 15, the mass is 5, and we want to find the acceleration. We divide both sides by the 5, even here by the 5. The acceleration is going to be equal to 15 divided by 5 is 3 meters per second squared. So as we can see, we have reduced the mass. The acceleration has now gone up. So what it means there is that the moment when the mass reduces, the acceleration is supposed to go up. The moment when the acceleration goes down, the mass has to go up. Okay, so this is what we need to know under Newton's second laws of motion. Okay, so we can also see that uh, Newton's second laws of motion, it can help us to find a lot of things. So we have got a question here which is saying a 6.0 kgs object undergoes an acceleration of 2 meters per second. What is the magnitude of the resultant force acting on it? If this same force is applied, that is part B, if this same force is applied to a 4.0 kgs object, what acceleration is produced? So now if we can check here, we are saying that we can see that we have an object. This object has got the mass of 6 kgs, and then the acceleration, we have been told that it is 2.0 meters per second squared. They want us to find the force. So according to Newton's second laws of motion, we know that the force is given by the mass times acceleration. So we want to find the force. The mass is 6 times 2. So the force is going to be equal to 12 newtons. Okay, so they are saying that if the same acceleration, if you have the same acceleration, but the force now has, the mass has changed to 4. So we are going to say that the same is going to be the mass times the acceleration. The acceleration is the same, the mass has changed to now 4. So now what we need to understand is that the moment we had the force, the mass which was 6 kg, 61 kgs, or it was 6 kgs, the force is 12 newtons. So now what it means there is that the moment when the mass reduces, the force is supposed to reduce as well, because the force and the mass, they are direct proportion to each other. Okay, so we have 4.0 now times 2. So we're going to get our force as 8 newtons. Okay, so this is what we need to know under Newton's second laws of motion. In this video, we are going to talk about Newton's second laws of motion. So Newton's second laws of motion state that the acceleration and mass, they are inverse proportion to each other. So what it means there is that if we have this, we are saying that we know that force is given by mass times acceleration. So if I want to find the mass, or I want to find the acceleration, I can divide both sides by the mass, even here by the mass. So I can say that the acceleration is going to be equal to the force divided by the mass. So as we can see here, that the acceleration and the mass, they are inverse proportion to each other. So meaning that the moment when the acceleration goes up, the mass has to go down. The moment when the acceleration goes down, the mass has to go up. So that is the relationship which is there between the mass and the acceleration. Okay, so if you have got an object which has got bigger mass, meaning that the acceleration has to be small. If you have got an object which has got small mass, the acceleration has to be greater. Okay, so now what it means there is that whenever we are talking about Newton's laws of second Newton's laws of motion, we are going to be considered to say the F net is going to be equal to the mass times acceleration. So this is the Newton's second laws of motion. So the acceleration and the mass, they're inverse proportion to each other. Now let's solve this question. This question is saying, as a fish jumps vertically up out of the water, assume that only two significant forces act on it: an upward force F exerted by the tail fin, and the downward force due to the gravity. A record Chinook salmon has a length of 1.5 meters and a mass of 61 kgs. If this fish is moving upward at 3.00 meters per second as its head first break the surface, and as an upward speed of 6.00 meters per second after two-thirds of its length has left the surface. Assume constant acceleration and determine part A the someone's acceleration, part B the magnitude of the force F during this interval. Now it is very important for us first to come up with data. Data is going to help us to know which formula is suitable for us to use. So we have been given the mass of the fish as 61 kgs. We have been given the initial velocity, which is 3 meters per second. We have been given the final velocity as the 6 meters per second. We have been given also the what? The displacement. Now we have been told that the displacement which we have, so we can say the change in x which we have been given is 1.5. But now we have been told that let's first come up with a free body diagram. So if this is the fish, okay, let me draw it here. If this is the fish, so they are saying that the length of this fish is just basically 1.5. So from here all the way to this part is 1.5 meters. Then they want us to find, they are saying that um, the question is saying that when it was out, the distance which was there, it was 2/3 of the total length. So 2/3 is 2/3. So this distance is the distance which was outside, meaning that this 2/3 is this one. So we need to find that distance. So we can say that is the change in x which we want to find. So to find this 2/3, we need to do times 1.5. Okay, meaning that as long as we find this, meaning that is the distance of the fish, the part of the fish which was outside water. So now what we need to do there is going to be 2 divided by 5. Oh, divided by 5 is 2/3. So it's supposed to be 2/3, not 5. 2/3. So it's going to be 2 divided by 3 times 1.5. So I'm getting 1. Meaning that my change in x now, it is 1 meter. That is the distance which was there when the fish was outside what? The water. Okay, now the first question is they want us to find the acceleration. So we have the data. Now. The change in x now is 1. This is the data which we have. So according to this data, the formula which it can help us to find the acceleration, since we don't have time, it can only be this. So we want to find the acceleration. The final velocity is 6. So we put 6 squared has to be equal to the initial is 3 squared plus 2. We want to find the acceleration. The displacement is 1. So we can shift this to the other side. We have 6 squared minus 3 squared is going to be equal to 2a, because 2 times 1 is just going to be 2. So we divide both sides by 2, even here by 2. So our acceleration is going to be equal to, we have 6 squared minus 3 squared. Everything divided by 2. So I'm getting 13.5 as my acceleration. So this is my acceleration. Now the next question is saying, so let's put our acceleration here. We are saying is 13.5 meters per second squared. The next question is saying, find the magnitude of the force during this interval. What it means there is that since they are saying that the only forces which are acting on this fish is we only have the upward force, which is the force which we are trying to find, and the weight due to gravity, the downward force. So which is going to be the weight of this object, the weight of this fish. So we can say that according to Newton's second law, the summation of all the forces in or we can say the F net, we are going to have what forces do we have? we have the upward force, which is F, minus the downward force, which is W, the weight force of the fish. So according to Newton's second law, we need to replace this with the mass times acceleration as long as we have acceleration. But if we don't have acceleration, meaning we replace this with 0. So we have acceleration, we are going to replace this one with mass times acceleration is going to be equal to the force minus this downward force is just basically m times g. So our goal is to find the force. What are we going to do? We are going to shift this to the other side. It's going to be the mass times acceleration plus mg is going to be equal to the force. So let's plug in the values. So we are going to have the mass, which is 61, times the acceleration 13.5, then plus the mass 61 times 9.8. So our force is going to be equal to, so we have 6.13, 6 times 13, oh it's 61, sorry, 61 times 13.5. So I'm getting 823.5 plus, so we have now 61 times 9.8. I'm getting a 597.8. So we add those two. So our force, the magnitude of the force is going to be 823.5 plus 597.8. So I'm getting a 1421.3. A 1421.3 newtons. So this is our magnitude of the force. So this is how you come up with the acceleration and the magnitude of the force. Okay. We have the next question, which is saying a person has a reasonable chances of surviving a car crash if the acceleration is no more than 30 Gs. Then calculate the force on a 70 kg person undergoing this acceleration. Then another question is saying what distance is traveled if the person is brought to rest at this rate from 100 kilometers per hour. Now, it is very important for us to know they are saying that it is 30 Gs. 30 Gs, what it means there is that it is 30 times 9.8. It's 30 times G. So the G is 9.8. Okay. So what it means there is that they want us to find the acceleration. Okay. So they are asking us to say calculate the force. So they want us to find the force. Okay. So let's come up with data first. So 30 Gs is going to be 30 times 9.8, which is going to be equal to, if we do 30 times 9.8 times 9.8, I'm getting 294. So we have 294. That will be our acceleration now, meters per second squared. And then what else do we have? So that is our acceleration. What else do we have? We have the mass of the person, which is 70 kgs. They want us to find the force. According to Newton's second laws of motion, the force is the mass times acceleration. So the mass is 17 times 294. So the force is going to be equal to 294 times 17, which is 20,580. 20,580 newtons. Okay, then part B is saying what distance is traveled if the person is brought to rest at a rate of at this rate from, so we have the force. Let's just put our force there. Maybe it's going to help us in question. We have this. So let's get rid of this. So they want us to find the distance. Okay. So to find the distance, we know that we have now the initial, we have been given, they are saying that we have now the initial velocity to say it was starting from what? The initial velocity is 100 kilometers per hour. Now, the final velocity, since it is brought to rest, is zero. The moment when you hear to say an object is brought to rest, the final velocity is zero, the acceleration is going to be negative. Okay, so they want us to find the displacement. Okay, so the displacement is going to be, we need first to convert this one into meters per seconds. So using dimension analysis, we can say that 100 kilometers per 1 hour is going to be equal to, so in 1 kilometer, how many meters do we have? We have 1,000 meters. We are done with that one, so we can cancel the kilometers and kilometers. Okay, so we now go to seconds. In 1 hour, how many seconds do we have? We have 360, we have 3,600 seconds. Is 60 times 60. So the hour and the hour will go. So we get our calculator and say 100 times 1,000 divide by 3,600. So I'm getting 27.777, so I can just say it's 27.8 meters per second. So this is now my initial velocity. I can put it there. My initial velocity is 27.8 meters per second. Now from here, what we need to do now is which equation, according to the data which you have, want to find the displacement. So the only formula, since we don't have time, the only formula which can work from the linear equations is going to be this. We have this. So we want to find the displacement. We know the acceleration, it is this one. But now since it was coming to rest, meaning that this acceleration has to be negative. So it's going to be 0 squared is going to be equal to, the initial now is 27.8 squared plus 2, the acceleration is going to be negative 294 times the displacement. You can either use D or X or even just S. It's okay. So we are going to shift this part to the other side. We are going to have negative 27.8 now squared. Okay. So we have this, and then this is going to be equal to, we have that one, if we do 2 times negative 294. Okay, I'm getting a 588, negative 588 times S. Divide both sides by 588, divide both sides by 5, negative 588. So we can see that our displacement is going to be equal to, negative and negative will go. So we're going to have our displacement, which is going to be 1.314 meters. Okay, that is what we need to know from there. And then we have another question, which is they are saying that police investigators examining the scene of an accident involving two cars measure 72 meters along a skid mark of one of the cars, which nearly came to a stop before colliding. The coefficient of kinetic friction between the rubber and the pavement is about 0.8 meters. Sorry, it's about 0.8. It's not meters, it's just 0.8. Then the question is saying estimate the initial speed of the car assuming a level road. Okay, so it is very, very important for us to know that when an object is moving, so we have got a car. Okay, we have a car. Now this car, the only force that is acting is the friction force that is bringing an object to rest. It's the friction force. So what we need to understand is that we are going to say that the summation of all the forces in x direction, since we're talking about the x direction, we're going to say that the summation of all the forces in x direction, when we know that according to Newton's second laws of motion, this is going to be mass times acceleration. So this part here we are going to replace with the force that is acting here. The only force that is acting is the friction force. Now, there is applied force, but we are not interested with the on applied force. We are only interested with what? The friction force. So the friction force is the one that was bringing an object to rest. So the friction force is always negative. So we're going to say that this is going to give us this. It's going to be equal to the mass times acceleration. So from here, we want first to find the acceleration. So the friction force is always mu times the normal force. So it's going to be mu times the normal force is equal to mass times acceleration. Normal force is mg. Okay. The normal force is mass times gravity. Okay. So we're going to have this. So we can cancel the mass. And then we can see that our acceleration is going to be equal to the mu, negative mu times g. So you can see that acceleration is going to be equal to the mu is 0. So it's negative 0.8 times 9.8. So our acceleration is going to be equal to negative 7.8 meters per second squared. So that is our acceleration. Now they want us to find the initial velocity. So we can see that our data here we have the distance, which is 72 meters. The initial velocity is the one we are trying to find. When it comes to rest, the final velocity is going to be 0. So we have acceleration as negative 7.8. So from here, which formula can it help us to find the initial velocity? Since we don't have time, the only formula is this. So we have the final velocity 0 squared. The initial velocity is the one we are trying to find. It's going to be plus 2. The acceleration is negative 7.8. The displacement is 72. We shift this to the other side. We are going to have negative v initial squared is going to be equal to. So we have 2 times negative 7.8 times 72. So I'm getting a 1123.2, negative 1123.2. So you can see that we have negative both sides, so we can cancel the negative. Then we're going to have this. It's going to be equal to this. So we get the square root both sides. You can see that v initial is going to be equal to, so the square root of this, I'm getting 33.5 meters, 33.514 meters per second. So that is our initial velocity. So this is how we can use Newton's second laws of motion to come up with a lot of things. Okay. In this video, we are going to talk about Newton's third laws of motion. So Newton's third laws of motion state that for each force exerted on one body, there is an equal but opposite direction. So what it means there is that if you have got, let's say we have a wall, and then there is a car which is coming, the car bumps into this wall. Okay. Now, the force that the car is going to use to bump into the wall is going to be the same as the force that the wall is going to exert on the car. So let's say that the force the car exerts on the wall is 100 newtons. So we are saying that for each force exerted on one body, there is an equal but in opposite direction. The force is going to be the same, but it's supposed to be in opposite direction, meaning that the force that the wall is going to exert on the car is going to be negative 100 newtons. It's going to be equal but in opposite direction. Okay, now this law is what we call the law of action and reaction. So the third law is also known as the law of action and reaction. Okay, so that is what we need to understand about Newton's third laws of motion. In this tutorial, we are going to talk about contact forces. So contact forces, we need to know that we have two types of motions there. We have second Newton's laws of motion and third laws of motion. Okay, remember, second Newton's laws of motion state that the F net is equal to the mass times acceleration. Third Newton's laws of motion says that for every action there is equal but in opposite direction, meaning that the force that m1 is going to be exerting on m2 is going to be the same as the force that m2 is going to be exerting on m1 but in opposite direction. So if the force that m1 is exerting on m2 is 2 newtons, meaning that the m2 is going to be exerting negative 2 newtons on m1. Okay, so here is a question for you. Two blocks with m1 is equal to 3.2 kgs and m2 is equal to 4.1 kgs are touching each other on a frictionless table. If the force F is equal to 6.8 newtons, part A, what is the acceleration of two blocks? Part B, with what force does m1 pushes against m2? Part C, repeat A and B if F is in the reverse direction and pushes on m2 rather than on m1. Okay, so for us to find the acceleration of the system, these two blocks, they're in contact, meaning they are moving with the same acceleration. So to find the acceleration, we are going to say that the summation of all the forces in y direction, in x direction, we are going to have what forces do we have? The only force that makes the whole system to go in this direction, it is the applied force. So we have two masses, we have to add those masses. So I can say that m1 plus m2 then times the acceleration is going to be equal to the applied force. We divide both sides by m1 plus m2, even here m1 plus m2. Therefore, acceleration is going to be equal to the mass, the force divided by m1 plus m2. Let's plug in the values. We see the acceleration which we are going to get. Okay, so we are going to have acceleration is going to be equal to, the force is 6.8, the mass we have 3.2 plus 4.1. So the acceleration which you are going to get here, if you plug in the values, it's going to be if I plug in, so I'm getting acceleration as 0.9315 meters per second squared. So that is the acceleration I'm getting. So this is the acceleration for both m1 and m2. Okay, now from here now, let's go to part B. Part B is saying with what force does m1 pushes against m2. So what we need to understand is that according to Newton's third law, the force that m1 is going to be exerting on m2 is going to be the same as the force that m2 is going to be exerting on m1, but in opposite direction. Okay, so we can just get m1 and put it here to say we have the applied force, which is 6.8. Then we also have this force, which is the contact force, which is in the opposite direction. Okay, now this force is going to help us to find, this is going to be the force that m1 is going to be exerting on m2. Okay, so we are going to say that this is our m1, which we are talking about. So the summation of all the forces in x direction, we have the applied force minus the contact force. So according to Newton's second law, this part we replace it with, as long as we have acceleration, we replace it with mass times acceleration. So we're going to have the mass times acceleration is going to be equal to the force minus this. Our goal is to find this. We can shift this to the left hand side and shift this to the right hand side. So it's going to be this, it's going to be equal to the force minus mass times this. So we have this, it's going to be equal to, this is 6.8 minus, the mass is 3.2 times the acceleration is 0.9315. Okay, so if I get my calculator, the answer I'm getting is 3.82 newtons. Part C is saying Repeat A and B if F is in the reverse direction, pushes on M1 rather than on M2, or M2 rather than on M1. So here they want us to repeat now. They are saying that this one is supposed to be in the opposite direction. So if we apply it in this direction, the answers which we have on A and B, since we are reversing them, meaning that the same answers but it's supposed to be negative. There's no need of us now calculating, but since it is, we are saying that according to Newton's second law, this is going to be the same force. So it is going in opposite direction. Definitely it's going to be the same, but the sign has to change. Okay. So now let's say we have the friction. How do we tend to find the acceleration? How do we tend to find the contact force? The force that M1 will be exerting on M2. Okay, so let's say we have the friction. Okay, the friction, let's say that the mu value is 0.03. Okay, then let's now find acceleration, part A and part B. Okay, so we need to know that we are going to say that the summation of all the forces. What forces do we have in x direction? Now we can see that we have the applied force and the friction force. Friction force always opposes motion, so it carries negative. So it's going to be minus in the friction force. So according to Newton's second law, we know that this part, as long as we have acceleration, replace that part with mass times acceleration. So it's going to be the m1, since we have two masses, m1 plus m2 times acceleration is going to be equal to the force minus the friction is mu times the normal force. So we know that normal force is just basically mg. So which is the same, I've just replaced there. Let's divide both sides by m1, m2, even here by m1, m2. Let's cancel these. So we have our acceleration as the force minus the mu mg divided by m1 plus m2. Okay, so we have, what do we have now? Let's plug in the values. We see the answer which we are going to get. So we have the applied force, which is 6.8, minus the mu value is 0.03. Then we have the mass. We need to add the masses because we are talking about those two blocks. They're in contact. Okay, so the mass is supposed to add. So we are going to say 3.2 plus 4.1 is giving me 7 times 7.3 times 9.8. Okay, so what are we going to get now? So we have everything divided by, we have the 3.2 plus 4.1. Okay, let's see what we're going to have. So our acceleration is going to be, we have 6.8, then minus, open brackets, we have 0.03 times 7.3 times 9.8. I close the brackets. So I'm getting 4 point, on top I'm getting 4.0658. We divide this one by 3.2 plus 4.1 is going to give us 7.3. So this divided by 7.3. So I'm getting our acceleration as 0.5569 meters per second squared. So we can just say this is the same as we have we can just round it off and it's going to be 0.56 meters per second squared. So that will be our acceleration if we have what? The friction. Now how do we find the contact force if we have the friction force? The force that M1 is going to be exerting on M2. Okay, so here is what we are going to do. Okay, the force that this is going to be exerting on that one is going to be the friction force. So what we are going to do there is we are going to say that um, the summation of all the forces, I'm talking about m1 in x direction, is going to be, what force are we going to have? We're going to have 6.8, the applied one, minus the friction force. The friction force is going to be mu times the normal. So let's just write the formula here. We have the force minus the friction force. Okay, now friction force, now we are going to get only one force there, which is going to be, this is going to be m1 times a is going to be equal to 6.8 minus, we have, this is going to be mu times the normal force, which is mg. Our goal is to find, in short, we are going to find the contact force is going to be the friction force. So you can just put there as a friction force, which is the same as if you can just find friction force using this. Okay, so you repeat, but see, if you repeat this process, you are going to see that the same answers, but they are supposed to be negative. Then that will be the correct answers. Okay, so this is how you get to find the acceleration with and without friction. Okay, so let's talk about elevators. So here's the question for you. A 45 kg woman stands on a spring scale inside an elevator. The scale reads the force with which it pushes upward on the woman. What does the scale read when the elevator is accelerating part A upward at 3.65 meters per second squared, part B downward at 3.65 meters per second squared? Okay, so let's have the elevator. So here is the elevator. So we are going to have the scale of the elevator. The scale of the elevator always leads the normal force. So let's say we have a person. Now, we know that the surface of the elevator is going to exert the normal force. So we're going to have the normal force. At the same time, the person is going to exert the normal force. Sorry, the weight force. Okay, whenever an elevator is accelerating upward, the acceleration is positive. When an elevator is accelerating downward, the acceleration is negative. Therefore, we can say that the summation of all the forces in y direction, what forces do we have? The forces acting on this person who is inside the elevator, there are only two: the normal force and the weight force. So the normal force is pointing upward, is going to be positive, minus the weight force is going to be negative. That's the reason I'm putting minus. According to Newton's second law, we can see that this part here we're going to replace with mass times acceleration. So we're going to have the mass times acceleration is going to be equal to the normal force minus weight force is just basically mg. So we are saying that the elevators always leads the normal force. So I can shift this part to the other side to make the normal force as a separate formula. So it's going to be the mass times acceleration plus mg is going to be equal to the normal force. So I can factor out the mass. It's going to be acceleration plus the g. So this formula is the one which is going to help us to find any kind of elevators. So to find the value, we always use this formula on elevators. Okay, so as we can see, the elevator will always lead the normal force. So the scale will always lead the normal force. That is the key point which we have to understand. So from here now, we can go ahead and solve these questions. So we have the first part here, which is saying, what does the scale reach when the elevator is accelerating upward? So when it is accelerating upward, this acceleration is going to be positive. So we have, this is the general formula, the mass acceleration times g, plus g, sorry. So we plug in the values. We're going to see that this is going to give us, the mass is 45. The acceleration is what? Is positive 3.65 plus 9.8. So the answer I'm getting is 605.25 newtons. Next, part B, you can pause the video and solve part B. So just consider the acceleration negative because it is going downward. Okay, so let's go ahead and solve part B. So we are saying that the general formula is this. So we have the normal force, so we have 45, then now it's going to be negative 3.65 plus 9.8. The answer I'm getting 276.67. Okay, so that is it for this video. Let's talk about tension force. Tension force is the force supported by the loop. So let's say we have a block and then this is supported by the loop. So the force that is being supported by the loop is what we call the tension force. Okay, now let's say that this block has got the mass of 20 kgs. Okay, let's find the tension force. Now this object is not moving. Therefore, the summation of all the forces in y direction, when we add them, they're supposed to give us 0. Okay, so what we're going to do now is we are going to say that what are the forces that are acting on this object. We have got the weight of this mass, which is going to be the W, which is just basically mg. So we can say that the forces which we have is the tension force, which is pointing upward, minus the mg, which is the weight force, has to be equal to 0. So to find the tension force, we shift this to the other side. So the tension force is going to be equal to the 20 times 9.8. Okay, so tension force in this case is going to be, we have the 20 times 9.8, which is 196. So 196 newtons, that will be our tension force in this case. Okay, so let's say we have the blocks which are sliding on the table. So we have this, then let's have the blocks. Okay, now here is a loop. So that is going to be our tension force. So let's say this is M1, this is M2. Let's say that the force that is pushing these blocks is just basically 20 newtons, meaning this is our applied force. Okay, so let's say that M1 is 3 kgs and M2 is 5 kgs. Okay, so there we go. The first thing is we need to find first the acceleration. The acceleration that is going to be pulling M1 and M2 is going to be the same. Okay, so we can say that the summation of all the forces in x direction, what force makes the whole system to move in this direction? It is the applied force. So the applied force which we have is just F. So according to Newton's second law, we need to replace this with mass times acceleration as long as we have the acceleration. So in this case, we want to find the acceleration. So we're going to say that this mass is going to be the combination of M1 and M2. Okay, so it's going to be M1 plus M2. Then we put them in brackets times acceleration is equal to the force. Let's divide both sides by M1, M2. Even here, M1, M2. So acceleration is going to be equal to the force divided by M1 plus M2. So let's plug in the values. The force which we have is 20. The M1 is 3 plus M2 is 5. So our acceleration is going to be, that is going to be 20 divided by 8, which is going to be 2.5 meters per second squared. So that is the acceleration that is pulling both M1 and M2. So since these two blocks, they are connected to the same loop, that's the reason why the acceleration is going to be the same. Okay, so the acceleration that this is going to be moving with is going to be 2.5 meters per second squared. Same applies to M2. It's going to be 2.5 meters per second squared. Okay, so there we go. We want to find the tension force. Now, finding the tension force is either you can use M1 or M2, but we are going to find the same answer. Okay, so let's start getting the tension force using M1. So we have our block, which is M1 here. So this block has got only tension force. Okay, so we are going to say that the summation of all the forces in x direction. What forces do we have that are acting on M1? We have only tension force, so we're going to say it's going to be equal to the tension force. According to Newton's second law, we replace this with mass times acceleration. So it's going to be the M1 times acceleration is going to be equal to the tension force. So the M1 is 3 times the acceleration is 2.5. It's going to be equal to the tension force. So T is going to be equal to if we do 3 times 2.5 is 7.5. So we're getting 7.5 newtons. Okay, now we can also use M2, but we need to get the same answer. So if we use M2, what are we going to have? Let's see. So M2, we can see that the summation of all the forces in x direction, we have two forces, the applied force minus the tension force. The tension force in this case is going to be pointing toward negative x direction. So we're going to have the applied force minus the tension force. According to Newton's second law, this is going to be equal to the mass times acceleration. So we have M2 times A is going to be equal to F minus T. Our goal is to find the T. So we can shift this to the other side. Again, this to the right hand side. So we're going to say that T is going to be equal to the force minus M2 times A. So tension force is going to be equal to, what is our F is 20 minus, we have the mass, which is 5 times 2.5. So this is going to give us, we have 20 minus, open brackets, we have 5 times 2.5. So I'm getting 7.5. So both methods, they are correct. Okay, so let's say we have 3 blocks now. We have the same one. Now we have 3 blocks. We have M1, M2, and M3. Okay, so we have M1, M2, and M3. In this case, we are going to have 2 tensions. So let's say this is T1, this is T2, and the force that is pushing these 3 blocks is 50 newtons. Find the tension T1, T2, and the acceleration in the system. So to find the acceleration in the system, this is what we're going to do. The summation of all the forces in x direction, the force that makes the whole system to move in this direction, it is just the applied force. So we have that force. So according to Newton's second law, this part has to be replaced by mass times acceleration, as long as we have the acceleration. So it's going to be mass. Now this mass is going to be the combination of M1, M2, and M3. Okay, times acceleration is going to be equal to the force. Divide by mass, we divide both sides by mass. Acceleration is going to be equal to the force divided by mass. So we can see that the force, we have been given the 50 newtons. The mass is going to be, let's say that M1 is 3 kgs, M2 is 5 kgs, and M3 is 8 kgs. So we have 3 plus 5 is going to be 8. 8 plus 8 is 16. Okay, 16 kgs. So our acceleration in the code is going to, or our acceleration in the system is going to be 50 divided by 16 is going to give us 3.125. 3.125 meters per second squared. So that is the acceleration. Now, let's find the tensions. We have T1, T2, and we have T1 and T2. So here, what we're going to have is, let's start with T2. Why are we going to start with T2? Because I have the applied force in this case. So it's going to be simple for me to start with M2, which is going to be M3, sorry. This is M3. So we're going to say that the summation, let's get we get M3. We have the applied force, which is 50 newtons, and the tension force, which is T2. Therefore, the summation of all the forces in x direction, we have the applied force minus the tension force. So T is T2. So according to Newton's second law, this has to be replaced with mass times acceleration. So we have m3 times A is going to be equal to the F minus T2. Our goal is to find the tension force. We can shift this to the other side and this to the other side. Okay. So what we're going to have there is going to be T2 is going to be equal to the force minus m3 times A. So let's plug in the values. We see the tension which we're going to have. So we have the force, which is 50, minus the mass is 8 times 3.125. Okay, so T2, if we get our calculator, we say 50 minus, open brackets, we have 8 times 3 point, we have 3.125. So I'm getting 25. So my tension force is going to be 25 newtons. That is T2. Now, how do we get to find T3 or T1? Sorry. So T1, we are going to use M2. Okay. So if we use M2, we can see that what we are going to have is going to be, let's get rid of this. Let's get the M2. So M2, we are going to have the tension force, which is T2. We have found that it's 25 newtons, and the what? The T1 in this case. So it's going to be the summation of all the forces. The summation of all the forces in x direction. What forces do we have? We have T2 minus T1. T1 is pointing toward negative x-axis. That's the reason why it's negative. So according to Newton's second law, this part has to be replaced with mass times acceleration. So it's going to be m2 times a is going to be equal to T2 minus T1. Our goal is to find the T1. I'm going to shift T1 to the left hand side and M2A to the right hand side. So it's going to be T1 is going to be equal to T2 minus M2A. So we have T1 is going to be equal to, let's plug in the values. T2 is 25 minus the mass M2 is 5 times 3.125. Okay, so our T1 is going to be 25 minus, open brackets, we have 5 times 3.125. So I'm getting 9.375 newtons. So that is T1. So this is how we get to find the tension force in this kind of questions. Okay, so let's get to have different questions. We see how we can find the tension force. Let's say we have got the block. Now we have got two tension forces which are acting. Now they're acting at an angle. So let's have those. And let's say that this is T1, this is T2. Let's say that these are applying at an angle. Let's say that the angle there is 30 degrees and the angle here is 45 degrees. Okay, so we do know that T2 is going to have the x component and the y component. So let's say that the mass of this block is 30 kgs. We know that if this object is not moving, it is at static equilibrium, meaning that all the forces in x direction, when we add them, they're supposed to give us 0. All the forces in y direction, when we add them, they're supposed to give us 0. So we know that this block is going to have the weight force. So we can say that we have the weight force, which is mg. Okay, so from here we can see that this is going to be tx, t1x, this is going to be t1y, this is going to be t2y, this is going to be t2x. So the summation of all the forces in x direction, we add them, they're supposed to give us 0. We have T1 pointing toward the positive x direction. So we have T1x minus, I'm putting minus because T2 is pointing toward negative x. So I'm going to have this. It's going to be equal to 0. So I'm going to have T1x is going to be equal to T2x. So I know that the x component of T1 is going to be cos. So it's going to be T1 cos C. What we have, the angle which is 30 has to be equal to T2 cos 45 degrees. So I can call this as equation 1 because our goal is to find T1 and T2. So we don't have T1, we don't have T2. So it's more like we have two unknown variables. So if we have two unknown variables, we need another equation which is going to help us to find these values. So let's just rewrite this. We have T1 cos 30 has to be equal to T2 cos 4 cos 45, equation 1. So let's get rid of this. Now let's go to y direction. As we can see in y direction, we can say that the summation of all the forces in y direction, we add them, they're supposed to give us 0. What forces do we have in y direction? We have got T1 y plus, is pointing up, so it's going to be plus even T2y minus. Now this is pointing down, that's the reason why I'm going to put minus. Okay, so it's going to be minus mg. It's the weight force, has to be equal to 0. So I can shift this to the other side. I can say that it's going to be T1 y plus T2y is going to be equal to, the weight force is mg. So we can just plug in. We know that the y component is going to be sine. Okay, so it's going to be T1 y. We are going to have sine 30 degrees, and then we're going to have plus T2 sine 45 degrees. Okay, has to be equal to, that one we have 30, the mass is 30 times 9.8. So to reduce this, we are going to say that this is going to give us this. T2 sine 45 has to be equal to 30 times 9.8 is 294. Okay, cool. So we know that this is going to be our second equation, so we can just put it there. Let's put our second equation here. We have T1. We're not supposed to put y here though. So this is supposed to be just T1 sine 30. So we have T1, we have T1 sine 30, and then plus T2 sine 45 has to be equal to 294. So this is our second equation. Now we have two equations. We can make, on equation 1, we can make T1 as a subject of formula and plug in the values in second equation, and then it's going to help us to find T2. So the first equation is T1 cos 30 has to be equal to T2 cos 45. So let's make T1 as a subject of formula. We divide both sides by cos 30, even here by cos 30. So we can see that T1 is going to be equal to T2 cos 45 divided by cos 30. Okay, so this is what we have now, meaning that in the second equation, where there is T1, we can plug in what? So let's just put this here. T1 is equal to T2 cos 45, everything divided by cos 30. Okay, so where there is T1 in the second equation, we are going to plug in T2 cos 45 divided by cos 30. So this is our T1. So we are going to plug in there. So we're going to say that T1, where there is T1, we put what? We put T2 cos 45. Everything has to be divided by cos what? Cos 30. Okay, so this is going to be times. Now we have the sign here. Let's not forget that. We have sine 30. Then this has to be plus T2 sine 45 has to be equal to 294. So now we can get our calculator, and then we are going to find what is cos 45 times sine 30 divided by cos 30. Then that answer which we find, we do plus sine 45. Okay, so if that is what we have there, we are going to find that we are going to have 1.1154 T2 plus, we have already done the plus there, so it's going to be T2 and then has to be equal to 294. So we can divide both sides by 1.1154, even here by 1.1154. So T2 is going to be equal to these, they'll cancel. So our T2 is going to be So our T2 is going to be, we say 294 divided by 1.1154. We are going to get we're going to get 215.215. Okay, I'm getting 215.215 newtons. This is what I'm getting. Okay, now to get the value of T1, we know that at first we made A, this is supposed to be T2. Okay, the formula, remember we made our T1 as a subunit of formula here. So we can just plug in the value of T2 and then find the T1. Okay, so we have T1 is going to be, T2 is 215.215, then you have times cos 45, everything divided by cos what? Cos 30. So if you plug in the values here, we have 215, we have 215. Okay, I think here we made a mistake. This part here, it wasn't supposed to be this, because after plugging the values, let's just go back a bit. Okay, we had what? Let's go back a bit. We had this. So after plugging in the values, what we were supposed to find here was I found 1.1154 T2 was equal to 294. So after dividing both sides by 1.154, even here 1.1154, our T2 is supposed to be, if I do 294 divided by 1.1154, I'm getting a 263.583 and not 215. Okay, so that is the value of T2. Now let's go ahead and find T1. So what we are going to have there is we are going to have our T2, our T1. We want to find T1. Remember we made our T1 as a subunit formula in this case. So we are going to plug in the value of T2. Then it's going to be, T2 is going to be 263.583 times, we have now cos 45. Then we divide everything by cos 30 degrees. So after plugging the values, we can see that 263.583 times cos 45 divided by cos 30. What I'm getting here is 215. Now this T1 is the one which is 215.215 newtons. So this is how you get to find the tension forces in this kind of questions. Okay. In this tutorial, we are going to talk about pulley system. Okay, so we have two types of pulley system. The first one which we're going to do is when the block is sliding on the table. So here is the table. Okay, the block is sliding on the table. So we have that. So let's say that this is M1, this is M2. Okay, and then let's say that M1 is 80 kgs, M2 is 5 kgs. So there is no friction at all. How do we get to find the acceleration and the tension in the system? So we have those tensions. Okay, so we can say this is T1, this is T2. But what we have to understand is that in T1 and T2, they are going to be the same because they are connected to the same rope. Okay, so here is the simple method which we have to take for us to find the acceleration. We know that M1 has got bigger mass than M2. Therefore, the weight of M1 is greater than the weight of M2. So the system is going to go in this direction. So the only force that makes the whole system to go in this direction is the weight of M1. Okay, so we are going to say that the summation of all the forces is going to give us what? The weight force. The weight force is the only force that makes the whole system to move in this direction. Okay, now we know that according to Newton's second law, where there is this, we put mass times acceleration as long as there is acceleration. Okay, so we are going to replace this, but we are talking about two objects. M1 is not only overcoming, the weight of M1 is not only pushing M1, but it is also pushing M2. Therefore, the mass, we have to add the masses. So we are going to say that M1 plus M2, then we put them in brackets, times the acceleration. This has to be equal to the weight force. Now the weight of um, which is going to be equal to m1g. So this is going to be equal to m1g. Let's divide both sides by a. We divide both sides by, sorry, we are trying to find the acceleration. Okay, so we divide both sides by m1 plus m2, even here by m1 plus m2. So we can cancel these. We can see that acceleration is going to be equal to the m1 times g, everything we have m1, m2. So let's plug in the values. We see the acceleration which we are going to get. Okay, so we have acceleration is going to be equal to m1 is 8 times 9.8, everything divided by 8 plus 5. So acceleration is going to be equal to, we have 8 times 9.8, I'm getting 78.4, everything divided by, we have 8 plus 5. So the acceleration I'm getting is 6.03 meters per second squared. So that is the acceleration of the system. Now, since this system, block 1 and block 2, they are connected to the same loop, therefore the acceleration is the same. So this block is also is moving with the acceleration of 0.6.03 meters per second squared. Also this one the same. Okay. Now, how do we get to find the tension force? So finding the tension force is either you can use M1 or M2. So let's start with M2. So if you want to find the tension force using M2, let's have our M2 here. We have our M2. Now the only force acting here is the tension force. So we're going to have the tension force there. Then we have the mass, which is 5 kgs. Then this is moving with an acceleration of 6.03 meters per second squared. So what we're going to do here is that the summation of all the forces in x direction, the only force that we have here is the tension force. Okay, so according to Newton's second law, this part has to be replaced with mass times acceleration. So it's going to be m2 times a is going to be equal to the tension force. M2 is 5, acceleration is 6.03, has to be equal to the tension force. Therefore tension force is going to be 6.03 times 5, I'm getting 30.15. Okay, newtons. So that is the tension force. So this tension force which you have found using M2 is the same as the tension which is T1. So if you want to use T1 to get the tension force, or M1 to get the tension force, this is what you are going to do. So here is the simple steps. So we are going to say that this is our M1. So we have the tension force, we have the weight force. So the acceleration, this system is moving in this direction. Therefore, the acceleration is going to be negative. So we are going to say that the summation of all the forces in y direction. What forces do we have? We have the tension force pointing upward minus the weight force which is pointing downward. So according to Newton's second law, this part is supposed to be replaced by mass times acceleration. But in this case, the acceleration is negative because it is moving in negative y direction. Okay, so we are going to say that this is going to be negative mass 1 times A is going to be equal to the tension minus weight force is just basically m1g. Our goal is to find the tension force. What do we do? Okay, I'm going to shift this to the other side. So shifting that one to the other side, we're going to have m1g minus m1a is going to be equal to the tension force. So we can say that tension force, I can just factor out m1. So I'm going to have g minus a, then that will be my tension force. Now let's plug in the values. We see the answer which we are going to get if it's going to be the same as 30.15. So the tension force is going to be equal to, we have the M1 is 8, G is 9.8 minus 6.03. So we have 8 open brackets, we have 9.8 minus 6.03. Then I close the brackets. Okay, so the answer I'm getting 30.16 newtons. So as you can see, this is approximately equal to this. If we can just round it off, it's going to be 30.2 newtons. Even this one is going to be 30.2 newtons. Okay, so that is the simple method which we have to use for us to find the tension force and the acceleration. Okay, now there is another method which we have to use for us to find the tension force and the acceleration. So here is the method. We start first with, I'm going to start with M1. Okay, so I'm going to get my M1 here, and this is my M1. Okay, if this is my M1, then I know that I'm going to have this is the tension force which is pointing up. I have got the weight force which is M1G. The acceleration is going down, so it is negative. So we are going to say that the summation of all the forces in y direction, we have the tension force minus M1G. According to Newton's second law, this part has to be replaced with mass times acceleration. So to specify, is M1A is going to be equal to T. So let's say this is T1. So it's going to be T1 minus M1G. Let's make T1 as a subject of formula. We shift this. So this is supposed to be negative. Let's not forget. We shift this to the left hand side. So we're going to have the tension force T1 is going to be equal to M1G minus M1A. Let's call this one as equation 1. Okay, so let's go to equation to M2 now. So I'm going to get rid of this to create space. I'm going to get rid of this as well, so that we have space. So we have our first formula, T1 is equal to M1G minus M1A. Now let's go to M2. So here is our M2. We have only tension force. So we are going to say that M2, we are going to say the summation of all the forces in x direction. The only force acting on M2 is tension force. So according to Newton's second law, this, as long as there's acceleration, that has to replace with mass times acceleration. So it's going to be M2 times A is going to be equal to the tension force. So I'm going to call this one as equation 2. So I can put it here to say tension force is equal to M2 times A. This is equation 1 and this is equation 2. Now what we need to understand is that we are saying that the tension is the same. So if the tension is the same, this is T2. Therefore T1 is going to be equal to T2. So where there is T1 here in this formula, where there is T1, I'm going to replace with T2. Okay, meaning that where there is this, I'm going to replace with M2 times A. So I'm going to say that this is going to give me M2 times A is going to be equal to M1G minus M1A. I'm going to shift this to the left hand side. So it's going to be M2A plus M1A is going to be equal to M1G. This is the same as, I can just write it and say M1A plus M2A is going to be equal to M1G. So now at this point, I can factor out I can factor out A. So A is going to be equal to, open brackets, M1 plus M2 has to be equal to M1G. Okay, then we divide both sides by M1 plus M2, even here by M1 plus M2. Therefore, the formula for calculating the acceleration now is going to go back to the one we had at first. Okay, so we can see that now these two, they will cancel. We are going to remain with acceleration is going to be equal to, we are going to have M1G, everything divided by M1 plus M2. So this is the formula. So if we plug in the values, we are going to get the same. the same answer. Let's plug in the values. We have got the mass m1, which is 8 times 9.8, everything divided by 5 plus 8. Okay, so we are going to get the same answer, which is a 6.03 meters per second squared. Now, to find the tension force, you use these equations which you have already come up with. So let's get rid of this. Now you use these equations. So we have found our acceleration. Let's put it here. We have found them, the formulas. We have two formulas for tension force. We made this and this. So if you want, you can use that one, the one for T2. M2 is a 5 times 6.03. This is going to give us 5 times 6.03 is going to give us 30.15 newtons, which is the same as 30.2 newtons. Okay, if we get this one, we are going to get the same answer as well. So you can plug in the values using that one, and then we are going to get the same answer at the same time. Okay, so that is how you get to find the tension force and the acceleration using both methods. Now let's assume to say we have the friction force. This system, we didn't have the friction. Now let's say we have the friction force. So let's say that we have the friction force, and let's say that the mu value, the mu k value is 0.13. Okay, so how do we get to find the acceleration? Using the first method, we know that the acceleration in this case is going to be the summation of all the forces, the force that makes the whole system to move. We know that this m1 is going to be pushing, the weight of m1 is going to be pushing, even it has to overcome the weight, the friction force which is acting on m2. So meaning that we are going to say that this is going to be the weight force, which is m1 g, minus the friction force. Friction force always opposes motion, so it always carries a negative. So according to Newton's second law, we know that this part here is going to be replaced by m1 plus m2, because we have two masses times acceleration is going to be equal to this. We know that friction force is mu times the normal force. We can divide both sides by m1 plus m2, m1, m2. We can see that acceleration is going to be equal to m1 g minus, we know that the normal force is just basically mg, so it's m2, because the friction force is going to be only on m2 because it is the one which is in contact with the table. Okay, m1 is not in the contact, m1 is in free fall, it is not in the contact with any surface. Okay, that's why we're going to get the normal force for only m2, so it's going to be m2g. Okay, so everything has to be divided by m1 plus m2. Okay, now from here we can now find the acceleration. So finding the acceleration there, we are going to see that acceleration is going to be equal to our m1. We can factor out g. Okay, since we have g, we can say this is going to be m1 minus mu times m2, everything divided by m1 m2. Let's plug in the values. So we have acceleration is going to be equal to, the g is 9.8, the m1 is 8 minus the mu value is 0.13 times the m2 is 5. So everything divided by 5 plus 8. So acceleration is going to be equal to, on top on there we are going to get it's going to be 0.13 times 5, and then I'm getting 0.65. So 8 minus 0.65, we are going to get 7.35. So this times 8, 9.8. Okay, I'm getting 72.03. I divide this by, we know that 5 plus 8 is just basically 13. So we divide that one by 13. I'm getting 5.54 meters per second squared. So as we can see, now we have applied friction. There is friction, then the acceleration has reduced, meaning that the system is going to move very slowly because of the friction. There's a force that is opposing the motion. Okay, so we have found our friction to be 5.54 meters per second squared. Now let's get to find the tension force. So you can pause the video and find the tension force. So finding the tension force is going to be the same. Let's start with M2. So M2, we have the tension force and the friction force which is opposing the motion. So we are going to say that the summation of all the forces in x direction, we have the tension force pointing toward positive x-axis minus the one which is opposing motion. According to Newton's second law, this part is going to be replaced by mass times acceleration. So it's going to be m2 times a is going to be equal to t minus this. We shift this to the other side. We're shifting this to the other side. So we're going to have m2 times m plus this is going to be equal to t. Now we know that the friction force is mu times the normal force. So it's mu times the normal force. Normal force for M2 is going to be M2G, has to be equal to the tension force. So let's plug in the values. Okay, so T is going to be equal to, we can plug in the values, or we can just factor out 2, M2, A plus mu, and then G. So we plug in the values, we have 5. Acceleration is 5.54 plus the mu is 0.13 times 9.8. So what are we going to get? The tension force which we are going to get there is going to be T is going to be equal to we have 0.1 0.13 times 9.8, then this plus 5.54. Okay, then the answer I'm getting times 5. So the answer I'm getting 34. Tension force I'm getting 34. I'm getting 34.07 newtons. Okay, so that is what I'm getting. So let's try to find the tension force using M1, sorry. So we have found that T1 is 34 point saying 34 point what? 34.07, which is going, it is the same as 34.1. 34.07. Okay, so what we're going to have now here is we're going to have this. We are going to say we get M2. We get M2, so we are going to have the M2. We have the tension force, the weight force, which is M1G. The acceleration is going down, is negative. Then we are going to say that the summation of all the forces in y direction, we have the tension force minus M1G. So this is going to be replaced by mass times acceleration. So it's M1A T minus M1G. Our goal is to find the tension force. We shift this to the other side. So it's going to be, so this is going to be negative because acceleration is going down, it's negative. Let's not forget that. So we are going to have now, we're going to have negative M1A plus M1G is going to be equal to the tension force, which is the same as tension force is M1G minus M1A. We can factor out the M1 is going to be G minus A. Okay, so here now we can see that the values which we are going to get, they are going to be simple. We are going to have T is going to be equal to, the M1 is 8, the G is 9.8 minus the acceleration is 5.54. So let's see what we're going to get. So we have 8. open brackets, we have 9.8 minus 5.54. So I'm getting the same. I'm getting t as 34.08. So this is approximately same as this one. So we can say that this is same as 34.1 and this one is also 34.1. So that is what we are going to that is what you're supposed to know for you to find the tension force and the acceleration with or without the friction. Now, if you want to use method 2, you can also try it out and you're supposed to find the same answers. Okay, so let's go to another type of pulley system where we have a pulley. Let's say we have a pulley. So here is our pulley, and then we have the system. We have two. So let's say this is M1, this is M2. Now we are going to say that this is tension 1, this is tension 2. Now, when the acceleration is going up, it is going to be positive. When it is coming down, it's going to be negative. So let's say that this is 5 kgs and this is 3 kgs. Okay, let's find the tension forces and the acceleration. So first, we know that M1 has got greater mass than M2. Therefore, the weight of M1 is going to be greater than what? M1 is going to be greater than M2. Therefore, the system is going to go in this direction. So the first method, the simple one, you can say that the summation of all the forces is going to be equal to the force that makes, we have got the weight. You can say W1. This is going to be another weight, which is going to be W2. So the force that makes the whole system to move is W1. But this W1 is supposed to overcome the weight of M2. So we are supposed to say minus weight 2. So according to Newton's second law, this part is going to be replaced by mass times acceleration. But we have two masses. So it's going to be M1 plus M2. Then you have this times acceleration is going to be equal to weight. This is going to be M1g minus M2g. We divide both sides by M1 plus M2. Even this side by M1 plus M2. We can cancel these. So our acceleration is going to be the M1g minus M2g. Everything divided by M1 plus M2. Let's plug in the values. We see the values which we are going to get. So now we have our M1. So if we want, we can factor out G. So it's going to be M1 minus M2. Everything divided by M1 plus M2. Okay, so let's plug in the values now. We see the answer which we are going to get. So we have acceleration is going to be equal to 9.8. We have M1 which is 8 minus 5. Oh, is 3 is 5 minus 3. Everything divided by 5 plus 3. So our acceleration is going to be, so acceleration in the system is going to be 9.8, open brackets, 5 minus 3. I'm getting 19.6. 19.6 divided by 3 plus 5 is 8. I divide that one by 8. I'm getting 19.6 divided by 8. I'm getting 2.45 meters per second squared. So that is the acceleration in the system. Now let's get to find the tension force. We can start with M1 and M2. We are supposed to get the same answer. Let's start with M1. So we have M1. The tension force we have is there. The weight force, which is M1g. Since it is coming down, for M1 the acceleration is going to be negative. So the summation of all the forces in y direction, we have the tension force minus M1g. So this is going to be negative because acceleration is going to be negative. 1 times A, we have this. The tension force, which is T1 minus M1g. We shift this to the left hand side. We are going to find that it's going to be M1g minus M1a is going to be equal to T1. We can factor out the M1. So it's going to be the T, it's going to be T1 is going to be equal to M1 open brackets G minus A. So we have T1 is going to be equal to, the M1 is 5, 9.8 is G, then we have 2.45. Okay, so we have 5 open brackets, we have 9.8 minus 2.45. So the answer I'm getting is 36.75 newtons. That is my tension force. I can also get the same answer using T2 or M2. Okay, if you want, you can use M2, you are going to find the same answer. Now M2, since the acceleration it is going up, the acceleration is going to be positive for M2. So to get the tension force, we are going to say that we have M2, we have the tension force, we have the weight force, which is Z, then the acceleration is going to be positive going up. The summation of all the forces in y direction, we have the tension force T2 minus M2G. According to Newton's second law, this part has to be replaced with mass times acceleration. So it's going to be M1 or M2A is going to be equal to T2 minus this. Our goal is to find the tension force. So it's going to be this plus M2G is going to be equal to T2. So I can factor out M2, A plus G is going to be equal to T2. Okay, so let's plug in the values. We see what we are going to have. So if we plug in the values, we can see that T2 is going to be equal to, we have 3 open brackets, acceleration is 2.45 plus 9.8. So we have 3 open brackets, we have 2.45 plus 9.8, then we close the brackets. So I'm getting exactly T1 as, or T2 as 36.75 newtons. So as you can see, both M1 and M2, they are giving us the same tension. Okay, so now there is another method, method 2, which can help us to find the acceleration and the tension force. So how do we get to use equation 2? And equation 2 is very much interesting because it's going to help us to find the tension force direct. So we can start with M1. So M1, we have M1 here. I can just get it from there to say the summation of all the forces in M1 is going to be, the tension force is pointing up minus the M1G. Then when it comes for the this part, we know that the acceleration is negative, so it's going to be replaced by M1A is going to be equal to T1 minus M2 or M1G. My goal is to solve for tension force. I'll shift this to the other side, so I'm going to have M1G minus M1A is going to be equal to T1. So this I can call it as equation 1. I can just put it here. T1 is going to be M1G minus M1A. This is equation 1. So let's go to T2 or M2. So M2, the acceleration is going to be positive now. Same procedure. The forces is T2 minus the M2G. But the acceleration is going to be positive because it is going up. So it's going to be M2A is going to be equal to T1, T2 minus this. Our goal is to find for the tension force. I'll shift this to the other side. So I'm going to say that this is going to be M2A plus M2G is going to be equal to the T2. So this is going to be my equation 2. Now what I'm going to do is, the tension is the same. Since they are connected to the same loop, the tension is the same. Therefore, I can replace this tension with what I have there. Okay, so I'm going to replace here T1. So I'm going to say that this is the same as, or let me just write this to say we have got now the T2, to say T2 is M2A plus M2G. So let's get rid of this. Now what we have to understand there is we are going to have, we know that T1 is going to be equal to T2. So T1 is M1G minus M1A is going to be equal to T2 is M2A plus M2G. So what we are going to do now is this. I am going to shift this part to the left hand side, and then I'm going to shift this part to the right hand side. Okay, so we are going to say that m1 g minus m2 g is going to be equal to m2a plus m1a. Now from here I want to find the acceleration. I can factor out the a. So let's just rearrange this. Can just put it there. We rearrange it the same as we start this part here. I can start with m1. It's okay. So I can say that that is the same as m1 a plus m2a is going to be equal to m1g minus m2g. So now here I'm going to factor out the a. So it's going to be a, open brackets, m1 plus m2 is going to be equal to m1g minus m2g. So we divide both sides by m1 plus m2, both sides by m1 plus m2. We can see that a is going to be equal to m1g minus m2g divided by m1 plus m2. So as you can see, the formula which we had at first is the same as this. Okay, so you can plug in the values, you are going to find the same answers. Now after finding the acceleration here, to find the tension force is going to be easy because we have already made the formulas, these formulas. You just plug in the values and find the tension force. So that is the basic idea behind the pulley system. Okay, so let's talk about pulley system. So we talked about two types of pulley system, where two blocks, they're sliding on the table, and another one is just in a free fall. Okay, and I hope you managed to watch the previous video which we just uploaded. Now in this case we have got this type of pulley system where we want to see how we can find the acceleration and the tension force. Now what we have to understand is that when we talk of pulley system, the acceleration in the system is the same. So what we're talking about is the acceleration for m1 and m2 is going to be the same. Okay, but what we have to understand is that m1 is under the influence of gravity. It is in free fall, so it's going to fall just because of the influence of gravity. So we have got the weight of m1, which is going to be m1g. Okay, then m2 is going to fall just because of what? It's going to be falling in this direction just because of the fg. And if you manage to watch the video on incline plane, we talked about fg. Fg is always mg sine theta. We talked about this. Okay, now what we need to understand is that the weight fg is just basically the gravitational force. Okay, so then the weight force for m1 sorry, is greater than m2. Therefore the system is going to move in this direction. So we can say that the summation of all the forces, the force that makes the system to move in this direction, is the weight force of m1. Now this weight force has to overcome the fg, so it's going to be minus the fg. Okay, that is very, very important. Now from there, what we need to understand is that according to Newton's second law, as long as we have acceleration, this part we have to replace with mass times acceleration. But which mass are we talking about? We're talking about two masses. We have got m1 plus m2. So we're going to say times acceleration is going to be equal to, this is m1 g minus fg is just basically mg sine theta. Okay, so what I'm going to do, I'm going to divide both sides by m1 plus m2, even here by m1 plus m2. So what I'm going to do here is that I'm going to cancel these. Okay, I'm going to have acceleration is going to be equal to m1g minus mg sine theta, everything divided by, we have m1 plus m2. So what I can do now is I have g on both sides. On top there I can factor out g. I can say that acceleration is going to be equal to g, open brackets, I remain with m1 minus m2 sine theta, everything divided by m1 m2. So as long as you have got this type of pulley system and there is no friction, in this case we don't have friction, this is the formula for finding acceleration. Okay, very very important. Now let's plug in and find the let's plug in and then we see the values which are going to have. We have 9.8 open brackets, m1 is 20 minus m2 is 10, then we have sine 30, the angle is 30. Okay, everything divided by 20 plus 10. So we're going to have acceleration is going to be equal to, we have 9.8 open brackets, we have 20 minus now what we have to understand is that sine 30 is 0.5, so we are going to say 10 times 0.5, which is going to be 5. So it's going to be 20 minus 5 inside there. 20 minus 5 is going to be 15. So it's going to be 15, 9.8 times 15, which is going to be for 147. 147 divided by 20 plus 10 is just basically 30. So I'm getting 4.9. So that is the acceleration in the system. Okay. Now let's get to know how we can find the tension force. So these two things, they are moving with the same acceleration. So both m1 and m2, the acceleration is the same. Now the tension force, you can either use m1 or m2, but we know that when something is going down here, the acceleration is negative. So if I'm going to use m1, I'm going to say that the summation of all the forces in y direction, we have t1 pointing up minus m1g. m1g is because it's pointing down. So according to Newton's second law, this part I'm going to replace with mass times acceleration. So it's going to be negative. Mass 1 times acceleration is going to be t1 minus this. I can shift this to the other side. Okay, it's going to be negative m1a plus m1g is going to be equal to t1. This is the same as t1 is going to be equal to m1g minus m1a. I can factor out m and say m1 open brackets g minus a. We plug in the values, so we are going to have t1 is going to be equal to m1 is 20, g is 9.8, then minus acceleration is 4.9. So let's find the tension force. That will be our T1. So we have 20 open brackets, 9.8 minus 4.9. So I'm getting 98. 98 newtons. That is the tension force which I'm getting. Now, if I use M2, I'm supposed to get the same answer. Let's use M2 now. Let's see if we're going to get the same answer. Okay. So we have the summation that is going to be in the x direction now. The summation of all the forces in x direction. When we add them, we are going to have the tension force, which is T2, minus Fg is opposing, so it's going to be Fg. So this is going to be M2 times A. Because it's going in this direction, it's going to be positive. The acceleration is going to be positive. So it's going to be T2 minus Fg is Mg sine theta. So we shift this to the other side, we are going to have M2 times A plus M2G sine theta is going to be equal to T2. So T2, I can factor out M, that's going to be M2A plus G sine theta. So let's see. We have our values. M2 is 10, acceleration 4.9 plus G is 9.8 sine 30. So let's see the T which we're going to get. We have 10. Okay, we have 10 open brackets. Then we have 4.9 plus, okay, plus then we have 9.8 sine 30. So sine 30 is 0.5. So 0.5 times 9.8 is 4.9. So it's going to be plus 4.9 inside there, which is going to be 98 exactly. So as you can see, if you use M1 and M2, we are going to end up getting the same answers. So that is part 1, or the first method which we have to use for us to find the acceleration. But there's also method 2. So we're talking about without friction. We're going to consider a situation where we're going to have friction. Okay, so part 2, we are going to start getting only M1. So only M1, we are going to find that the forces in y direction, when we add them, we're going to have the tension force, which is T1, minus M1G. So according to Newton's second law, as long as we have acceleration, this is going to be replaced by mass times acceleration. But we know that here the system is going to go down, the acceleration is going to be negative, so it's going to be negative. M1A is going to be equal to T1 minus M1G. I shift this to the other side. So it's going to be this plus this is going to be equal to T1. So I can rearrange this, and going to be T1 is going to be equal to M1G minus M1A. Let's call this one as equation 1. So I'm going to put this equation 1 here. T1 is M1G minus M1A. Equation 1. Let's now go to M2. So M2, these are forces in x direction. The summation of all the forces in x direction, we have the tension force, which is moving in that direction, T2, okay, minus the Fg. Fg is opposing, so this is going to be replaced by mass times acceleration. But in this case, since the object is moving in that direction, the acceleration is going to be positive and not negative. So it's going to be M2 times A is going to be equal to T2 minus C. Fg on an incline is mg sine theta, so it's going to be M2g sine theta. I shift this to the other side, it's going to be M2a plus M2g sine theta is going to be equal to T2. So I can say this is going to be my equation 2. So this equation 2, let me just put it here. T2 is going to be equal to M2a plus M2g sine theta. So let's get rid of this. Okay, so we are going to see that here we are going to have we know that tension is going to be the same. T1 is going to be equal to T2. So T1 is M1G minus M1A. It has to be equal to T2 is M2A plus M2G sine theta. Okay, I can rearrange them, and then I'm going to find that the ones which I'm going to have is I want to have the acceleration. I'm going to shift this acceleration to the other side. I'm going to shift the mg sine theta to the other side. So I'm going to have mg m1g minus, this is positive here, so it's going to minus when it comes this side. It's going to be m2g sine theta is going to be equal to, we have m2a plus m1a. So I can rearrange this. I can put this to the other side, this to the other side, which is just the same thing. So I can say that this is going to be m1a plus m2a. I've gotten just this, don't be confused, has to be equal to m1g minus m2g sine theta. Now I can factor out g on top. So if I factor out g on top, and then this left hand side I'm going to factor out m. Okay, so I'm going to have a is going to be open brackets m1 plus m2. Here I'm going to factor out g. It's going to be m1 minus m2g sine theta. So I can divide both sides by m1. Okay, so if I divide both sides, I'm going to find that acceleration is going to be equal to g open brackets m1 minus m2 g. Oh, g is not supposed to be there because we have factored out. So it's going to be sine, even here we have made a mistake, Here was not, we're not supposed to include g because we have factored out g. So it's supposed to be just m2. So it's going to be m2 sine theta, then everything divided by what? m1 plus m2. So as you can see, this is the formula which we found at first using the first method. So you can also use this method again. So if you want to find the tension force in this case, you just plug in the values direct. You have the acceleration, so this is the first formula, and here is the second formula. So you have your acceleration, just plug in the values direct and then find out the tension force which you're going to find. So if you use equation 1 and equation 2, you end up getting the same answer. Okay, so what if we have got pulley system which has got the friction? How can you find the acceleration? We are from solving the same question where we didn't have the friction. Now let's say we have friction. Now let's say the mu value is 0.33. Okay, so we know that friction always opposes motion. Okay, meaning that we have got two forces which opposes motion. In this case, we have got the friction force and the force of gravity. We know that on an incline, the Fg always brings an object down. Okay, so we're going to have the summation of all the forces. We're going to have this system is going to move in this direction just because of the weight of m1. Okay, so we're going to say that this weight of m1, which is the weight, has to overcome the Fg. At the same time, it has to overcome the friction force. Okay, now we do know that the normal force on an incline is going to be equal to mg cos theta. But in this case, which m are we talking about? We're talking about m2. So we can specify it and say this is going to be m2, even this one is going to be m2. Okay, so there we go. According to Newton's second law, we replace this part with mass times acceleration, but we have two masses, so we're going to add them. It's going to be m1 plus m2. Then we have times acceleration is going to be equal to our weight is m1g minus, this is going to get Fg is m2g sine theta minus the friction force is mu k times the normal force. Okay, so we know at this point we can divide both sides by m1 plus m2. Even here we divide it by m1 plus m2. So these two are going to cancel. We're going to have acceleration is going to be equal to m1g minus m2g sine theta minus mu. The normal force, we know that the normal force is m2g cos theta. Now from here we divide everything by m1 plus m2. Now what I'm going to do is I have acceleration is equal to m1g minus m2g sine theta minus mk, which is mu k, m2g cos theta. Everything is divided by what? M1 plus m2. Now what we have to understand here is that I can factor out, it is possible I can factor out the what? I have got common things here. I've got m2g and then I also have m2g where there is mu here. So I'm going to factor them out. So I'm going to have my acceleration to be equal to m1g minus, then I'm going to say I'm going to factor out m2g. Okay, I'm going to factor out m2g is going to be open brackets. Then I'm going to remain here. I'm going to remain with only sine theta. Now since this is negative here, I'm going to put plus mu k. Then I've remained with what here? I've remained with the mu k cos theta. So I'll put cos theta here. Okay, then everything is divided by m1 plus m2. Now we can plug in the values. Now we found that the friction without the acceleration without friction, it was 4.9 meters per second squared. The acceleration with friction, if the friction is present at that particular point, meaning that the acceleration which you have to find is supposed to be less than 4.9. Okay, if we're going to find that the acceleration is going to be greater than or equal to 4.9, then the answer is wrong, because friction always opposes motion, meaning that the system is going to be slow. Okay, So we're going to have acceleration is going to be equal to the m1 is 20 times 9.8. I'll put them in brackets minus m2 is 10 times 9.8. Then I'm going to put them in brackets again. I have got this. I have got sine 30 plus the mu value is 0.33. I don't have space there. I'm going to say times I have cos what? I have cos 30. Okay. Now everything is divided by m1 is 20 plus 10. So my acceleration is going to be equal to, we are going to start saying 20 times 9.8. I'm going to get 196. Okay, 196. Then I'm going to have minus. Inside there, I'm going to start first. I'm going to say I have got 0.33 cos 30. I'm getting 0.28, 0.285. This plus sine 30. So I'm getting 0.785. Now this one I have to say, what is 10 times 9.8? Which is going to give us 98. So we do this times what? 98. Okay? So I'm getting 77.00, which is just basically 77. So I divide it by 10 plus 20 is 30. So our acceleration is going to be, we're going to have 196 minus 77. Okay? So 196 minus 77, which is 119. So 119 divided by 30. So what would be 119 divided by 30? Let's see. Okay. So 119 acceleration is going to be equal to 119 divided by 30. This is giving me 3.96 meters per second squared. So this is correct because it is less than 4.9. So this is going to be the acceleration if the friction is present. Okay, now even the tension force is going to be different. So we can find the tension force. T1 and T2 is going to be the same because it is connected to the same rope. So let's start finding T1. You're going to discover to say if I find T1 and T2, I'm going to get the same answer. So you just choose. If you want to use M1, then you're going to find the tension force. If you want to use M2, you're going to find the same tension force. So now let's start with T1. We see if you're going to find the same with T2. Okay, so we are saying that the acceleration now is 3.96 meters per second squared. Now let's start with this one. We know that when this system is coming down, the acceleration is going to be negative. Therefore, the summation of all the forces in y direction is going to be, we have got the tension force which is acting upward minus the m1g. Now, according to Newton's second law, we replace this one with mass times acceleration. But in this case, since the acceleration is negative, it's going to be negative m m1a is going to be equal to t1 minus m1g. Okay, our goal is to find the tension force. I'll shift this to the left hand side and I'll end up having negative m1a plus m1g is equal to t1. So t1 is going to be m1g minus m1a. So now in this case, I can if I want, I can plug in the values direct, or I can factor out m1. I can say m1, I can say my m1 open brackets g minus a. So I can now plug in the values. So if I'm to plug in the values, this is what I'm going to have. Okay, so we have now that formula. So if we plug in the values, it's going to be t1 is going to be equal to, the m1 is 20 open brackets, the g is 9.8 minus the acceleration is 3.96. Okay, so what will be our t1? So our t1 in this case is going to be 9.8 minus 3.96. Then the answer I'm going to get times 20. So I'm getting 116.8. 116.8 Newton. So this is my tension force. Now I can also use M2 to find the tension force. And I need to get the same answer. So let's see if we're going to get the same answer. So we are saying that our T1 We have found that it's 116.8 newtons. Now let's use M2 to come up with the same answer. So in this case, we are going to say that the summation of all the forces in x direction. What forces do we have? We have got the tension force, which is going to be T2. Then we have got two forces which are opposing. We have got the Fg minus again the friction force. Okay. Now in that case, we are going to say that according to Newton's second law, we replace this with mass times acceleration. So it's going to be m. Now in this case, since this system is moving in this direction, the sign for acceleration is going to be positive. So it's going to be m2a is going to be equal to the t2 minus fg is going to be m2 g sine theta minus. So we are going to have, since I don't have space this side, let me start from this point here. We are saying that it's going to be mass 2 times acceleration is going to be equal to T2 minus this is Fg is going to be m2g sine theta, which is already here. Okay. Then I'm going to have minus, this is going to be mu k, then I have mg, which is mu times the normal force. So normal force is m2g cos theta. So it's going to be m2g cos theta. Okay. Now our goal is to find the tension force. I'm going to shift these two guys to the other side. Then I'm going to have my T2 is going to be equal to M2A plus M2G sine theta plus mu K M2G, then you have cos theta. So now we can plug in the values. Now we can also factor out M2. If we want, we can factor out M2 here. So it's going to be T2 is going to be equal to M2 open brackets A plus I'm going to have G sine theta, then again we have plus I'm going to have mu K, then G cos theta. Okay, so let's see if we're going to get the same answer. Let's plug in the values. So we have our M2, which is 10, then acceleration 3.96 plus G is 9.8 sine 30, then plus the mu value is 0.33, then we have G, which is times 9.8, then we're going to have cos 30. So let's see if we're going to get the same answer. So I'm going to do what is inside first. So I'm going to start with 0. What is 0.33 times 9.8? I'll start with this part here. I'll start with this part. Okay. So I'm going to say 0 times 9.8. This is going to give me 3.234. So 3.234. I'm going to say this cos 30. Okay. So I'm getting 2.8. Now this plus 9.8, then we have sine 30. Okay. Again this plus 3.96. So I'm getting inside there I'm getting so it's going to be T2 is going to be equal to 10 open brackets. Inside I'm getting 11.66. Okay, so that times 10, I'll be able to get 116. Okay, so my tension force is going to be 116. So T2 is 116.7. So this one now I can round it off and say this is the same as 117 newtons. Same applies to this one. I can round it off and say 117 newtons. So as you can see, if you use M1 and M2, you end up having the same answer. So this is what you're supposed to know under Pulley system, with or without friction. So let's talk about incline plane. So we have a diagram where we have been given a block which is on an incline. The block has got 5 kgs at an angle of 30 degrees. Okay. Now, how do we come up with the formulas on how to find the acceleration with or without friction? Okay, now if there is no force which is applied or which is acting on that 5 kg block, the only force that is going to be present at this particular point is the force of gravity. So the force of gravity always want an object to go down, so we're going to have the Fg in that manner. Okay, now this object, we know that we are going to have the normal force which is perpendicular to the surface. So here is our surface. Now the normal force is going to be directed in this direction, so that is going to be our normal force. Normal force is always perpendicular to the surface. Okay, so it's supposed to be making a 90 with the surface. Now from there we can see that if this is our normal force, the weight force is going to be directed in this direction. So here is going to be our weight force, which I'm going to say mg for now. Okay, now this mg weight force is going to have, for it to support the weight, the normal force is going to have the x component, or let me start with the y component as well as the x component. Okay, so according to the incline law, the theta which is going to be formed here is the same as the theta which is going to be there. So here we also have 30 degrees. Now what we have to understand is that we have um, more like a triangle. Okay, so this is our hypotenuse. Okay, then we have, this is going to be our opposite, this is going to be our adjacent, meaning that this point here I can say that this is mg sine theta, and then this is mg cos theta. Okay, so if there is only friction force, which is, if there is no friction, there is only Fg which is acting at that particular point, how do we find the acceleration? So we're going to say that the summation of all the forces, when we add them, how many forces do we have? The only force which makes the whole system to go down is the Fg. So I'm going to say that the Fg. So according to Newton's second law, I'm supposed to replace this with mass times acceleration. So I'm going to say that this is going to give me mass times acceleration is going to be equal to the Fg. Now we can see that the Fg is going in the same direction as mg sine theta. Okay, they're all going in the same direction. Therefore we can say that Fg is going to be equal to mg sine theta. Then we know that since the normal force, we know that when we are talking about the normal force, we always get the one which is in the straight line. So we have got the mg cos theta which is in the straight line as the normal force. Therefore the normal force is going to be equal to mg cos theta. So on an incline we need to take note of this. Very, very important. Okay, very, very important. We need to know this. We also need to know this. Very, very important. Now from here we know that Fg is mg sine theta. So I'm going to say that mg, ma is going to be, where there is Fg, I'm going to put mg sine theta. So I can see that I can cancel the a, I can cancel the a. Therefore my acceleration is going to be g sine theta. So this is going to be the formula for calculating the what? The acceleration. Let's plug in the values. We see the acceleration which we are going to get. Okay, so we're going to have the acceleration is going to be equal to, we have the g which is 9.8, then we have sine 30. So acceleration is going to be 9.8 sine 30 degrees. So we have 4.9. So 4.9 meters per second squared, that will be our acceleration in this case. Okay, that is the first thing we should have to know. Now let's say we have the incline. Now the object is moving in this direction. Okay, let's say we have that. Then let's say we have the angle which is going to be at 25 degrees. Let's have our object. Now we want to apply the force. Or before we do that, let's first say there is friction which is acting in this manner. Okay, there is friction there. So the friction which you have, okay, in short, let's say we apply a force. We apply a force of maybe let's say a 50 newtons. Let's say that the mass of the block is 50 kgs. How can we find the acceleration? Okay, now using the concept from the previous example, we know that the summation of all the forces, we are going to get what forces are present at that particular point. As long as we are talking about incline plane, the FG will always exist. So there is a force that is dragging this block in this direction, that is FG, and FG is always mg sine theta, and Fn is going to be equal to mg cos theta. Okay, now in this case we are going to say that the force which is present is the force which is moving in this direction. We have the applied force minus the Fg is opposing. Now the Fg is going to act as the friction force minus the Fg. Okay, so we're going to say that this is mass times acceleration is going to be equal to the applied force minus Fg is mg sine theta. Okay, so what I'm going to do is I'm going to divide both sides by mass, even here by mass, meaning that my acceleration is going to be equal to the applied force minus mg sine theta, everything divided by the mass. So acceleration is equal to the force is 50 newtons minus the m is 50. Okay, the F is 50 times 9.8, then we have times sine 20 degrees, everything divided by the mass, which is 50 kg. So what will be the acceleration? So we can say that 50 times 9.8, then this we have 490 sine 20. Okay, I'm getting 167, which is going to give us negative. Now let's reduce the mass. Let's just say that the mass is 5 kgs. Okay, so we need to put a 5 here. Let's reduce the mass to 5, because the mass and the force, they can't be the same. So we have 5 kgs times 9.8, then here we have also 5. So we're going to say that 5 times 9.8, then I'm getting 49, then we're going to say that 49 sine 20, which is give me 16.776. Okay, so I'm going to have this. My acceleration is going to be equal to 50 minus 16.76, everything divided by 5. Acceleration is equal to, so we're going to say that 50 minus 16.76, then everything divided by a 5. So I'm getting acceleration as 6.648 meters per second squared. So that is my acceleration. Now let's say that we have the same situation, and then there is a friction. There's friction which is acting in this direction. Okay, we have friction, and let's say that the mu value is 0.31. So to find the acceleration, we are going to say that the summation of all the forces, since we are talking about the summation of all the forces in x direction, we're going to have the force which is applying at this point. We have the applied force minus the friction force, but we also have another force which is opposing, the Fg. The Fg is pushing an object in this direction, in the same direction as the friction. So we're going to say that minus the friction force, or minus the Fg. Okay, then this is going to give us, according to Newton's second law, we replace this with the mass times acceleration is going to be equal to the applied force minus we are going to have, this is going to be mu times the normal force, that is the friction force, minus Fg is always mg sine theta. Okay, so from here I know that Fn is also mg cos theta, so I'm going to say that the mass times acceleration is going to be the applied force, okay, minus mu. Then here I'm going to have Fn is mg cos theta minus mg sin theta. Everything we can divide both sides by m, everything by m. So acceleration is going to be equal to the applied force minus, if I want I can factor out the mg. Okay, so I can say that mg, open brackets, I'm going to remain with mu cos theta minus, oh, here is going to be now plus, because negative and negative is going to give us positive. But if you want, you can just plug in the values direct there, you'll be able to find the same answer. So I'm just trying to make the formula to be simple and easy. So we are going to say that this is going to be sine theta, then everything we divide it by what? There is a mass. So we can say that this is our formula on how we can find the what? This has to be somewhere here. So this is going to be our formula for finding the acceleration. So let's try to plug in the values. We see the acceleration which we are going to get. Okay, so we have A is equal to mg. M is just basically 5 times 9.8. Then this, open brackets, mu is 0.31 cos 25. Okay, cos 25. I believe the previous example I used 20 instead of 25. Take note of that. So you can use 25. I used 20, the angle. I made a mistake. I used the 20 instead of 25. Okay, so we're going to have cos 25, then plus sine 25. Everything divided by what? A 5. So let's get rid of this. So acceleration is going to be equal to, we can say 5 times 9.8 is going to give us 49. So open brackets, we can have what is inside there. We have 0.31 cos 25. Okay, then this plus sine 25. So inside there I'm getting 0.7. So before I do anything, I can say this times, okay, we are going to say that this, but we had the force, the applied force here. I'm supposed to say that the acceleration is supposed to be the applied force, which is 50 minus, yes, and then here we have everything divided by 5. Yes, this, we forgot to put the force there. Take note of that. So what we have to do now from there is, I'm finding inside there, I'm finding, when I say 0.31 cos 25 plus 51, or plus sine 25, I'm getting 0.7035733675. So I'm going to say this times 49, because 5 times 9.8 is 49 times 49. This is going to give me 34.448. So we're going to have acceleration to be equal to 50 minus 34.48, everything divided by a 5. So acceleration is going to be 50 minus 34.48, then I divide this one by 5. So this is going to give me 3.104 meters per second squared. So this is how you find the friction in this kind of question, where you have only the Fg, you have only the applied force, then even if when they include the friction force, this is how you come up with the acceleration. Okay, so we have got a question under incline plane, which is saying a block of mass 5.8 kgs is pulled up at an angle of 25 degrees incline as shown in the figure below. With the force of magnitude 32 newtons, find the acceleration of the block if the incline is frictionless. Find the acceleration of the block, that is part B. Find the acceleration of the block if the coefficient of kinetic friction between the block and the incline is 0.10. Okay, now what we have to understand is